So good evening, everyone. Good evening, everyone. So we're going to be starting now, and because of our time, I don't want us to spend anything more than an hour, 30 minutes at most. Please, if you can hear me, just you can drop a chat at the chat box and just confirm that you can hear me. So we are going to be starting immediately today. And what we want to actually look at is we want to begin to practicalize uh, how to design a LAN. Okay, so uh, when we say a LAN, what does it mean? We've looked at all of those definitions, and we just don't want to um, just look at the definition alone. Okay, thank you, everyone. Thank you, chatting. I've seen your messages. Good. So we just don't want to look at it from definition point of view. We want to begin to see how to implement, how to design a network. And a network starts from a LAN. What is a LAN? We say a LAN is a local area network. A local area network. And when we are saying a local area network, we are talking about um, our switch connected to our PC, connected to our server, connected to our laptops. So we're going to see how that can be designed. And what is the purpose of having this network? We are saying for the purpose of sharing resources, sharing information. So, and in the last class, we're now beginning to look at some of the technologies that are available when we are setting up a LAN. So we're going to look at how to set up assigning IP statically, and then we now said, okay, there is what we call a DHCP server. So that is the major thing we want to design. So we're going to be designing it in two different perspectives, and those are the two ways you're going to have to share with me what you you are able to come up with. So we're going to be using the Cisco packet tracer. So if you can see my screen, please let me know. Can you see my screen, please? Hello?
Yes, sorry.
All right, thank you. So, and if you can see my screen, you should be seeing the Cisco packet tracer interface. Now, this is a simulator. We call it a simulator that it can help us to simulate how this thing will actually work in a real life scenario. For you to buy a Cisco router, especially an enterprise Cisco router or a switch, you're going to be spending sometimes thousands to some millions. So nobody will want to give you a brand new Cisco router to practice. So you need to get a place to learn. So that's what we call a simulator. And the simplest one is this Cisco packet tracer. Of course, Cisco packet tracer only enables us to be able to work with Cisco devices, such as Cisco router and so on. So tonight we now want to look at what a DHCP server is and how it can be designed. Okay, how do we design it? How do we set it up? And when we set it up, how do we test that it's working? So there are two ways that we're going to be doing this. We're going to have to set it up as a server on its own first, and then we'll now use a router. Excuse me. Sorry. All right. Then we now use a router to configure a DHCP server as well. So if you are going to set up yours, which is going to be our assignment, once you hover your mouse at the left hand corner down here, you see network devices. You see it here, network devices. This network devices includes our router, our switch. So when we click on it, you see end devices. End devices here are talking about your PC, your IP phone, your server. Those are the end devices. End devices are the devices that are connected to the switch. Okay, so then we have components, we have connections, which is cable, we have miscellaneous, and we have multi-user connections. But you are more concerned about network devices. And this is it. You see routers here, you see switches here, you see hub, you see wireless device, you see security, and cloud one. So let's start with our end devices. So the end devices we're going to be looking at is going to be our PC. So we see PC here, we see laptop here. We can just pick one. Let's pick about 4 PC. Let's just take 2 PCs and then 2 laptops. So we take 2 PCs and 2 laptops. We've powered up our Cisco packet tracer. So we have picked 2 PCs. We said we go down to the, for those that are just coming into the class, I wouldn't want to appreciate this next time, please. We said these are our network devices at the left hand corner of the simulator. This is the network devices. End devices. End devices, we said these are the devices that are connected to the switch that we need to assign IP to, either statically or via a DHCP. Now, we've picked 4 end devices, which are 2 PCs and 2 laptops. So let's say this is PC1, and we are giving it an IP of 192.168.100.20, or let's say 21. We've given it an IP of that. So let's say this is PC2, and we are giving it an IP of 192.168.100.22. Then PC3, which is a laptop. Remember, either it's a laptop or a PC, is still an end device. So we call it PC3, and we give it 192.168.100.23. So we are looking at the fourth PC. The fourth PC. The fourth PC, which is this next laptop, is PC4, and we are giving it 192.168.100.24. Now, how am I able to put this thing? All I need to do is to just double click on the PC icon. So let me bring up another end device. So like if I've brought up a new end device here, PC2, just click on this PC that is written here. You'll be able to type, change it to whatever name that you want. And if you want to delete it, you come up here on the left top corner. The first, second, and the third one, you will see it X. You will see it delete. When you pick the delete, you put it on top of the device you want to delete. It will ask you, do you want to delete PC2? Yes. So it's been deleted. Then you escape. Once you press escape, that's done. So we have already brought up our end devices, which are going to be connected to a switch. So we need a switch. Remember that is a switch that will allow these devices to be able to talk to one another. So if we bring our switch up here, so let's call it our LAN switch. LAN switch. Remember, we are setting up a LAN network. So this is our LAN switch. Then we have the switch. How do we connect the switch to the endpoints, or how do we connect the endpoints to the switch? We need connections. I showed us all of that at the beginning. So you see connections there. So you can use the automatic. This automatically choose the correct cable for you. So you can use this automatic cable. So you click on the device. So you click on the device. Since you already say automatically, it's going to assign it to the right port there. But then what I would say we'll do so that we can learn it very well. Let me delete this so that we can see it. I won't pick automatically. So I'll pick the right cable here, which is a copper straight through. Once I pick that, it will tell me all the ports that are on the. Are you seeing that now? You are seeing all the ports that are on the PC. It tells us that we have USB port 1, USB port 0, and RS232. Then we have fast Ethernet. This is the fast Ethernet. Remember when we were learning, I spoke something about NIC card, network interface card. That is the interface that the router or the PC is going to use to talk to the switch. That's where we connect our cable to. So you put the cable on that port and come to the switch. So since it's PC1, let's connect it to fast Ethernet 1. I'm just doing this design and I'm expecting your design to follow this same pattern. So look at it. If I put my cursor, that's my mouse cursor, on this cable, it should tell me what is connecting. You will see it that it's telling me that fast Ethernet 0 is connecting to fast Ethernet 1. So we pick the next cable, straight through again, go to fast Ethernet 0 to connect to fast Ethernet 0/2 on the switch. So let me move this one up a bit so we can move this up as well. So let's move to the next one. We pick our copper straight through again, move to the next PC, fast Ethernet 0, that's your NIC interface card, connect to fast Ethernet 3, and we go to the last one as well, and we pick the cable, and it goes to port 4. So this is a LAN subnet, or this is a LAN setup. With this, you have set up a LAN. However, these devices cannot talk to themselves except they have what? I don't know if anybody can remind me that. What would these devices need to be able to communicate with one another? Anybody want to tell me? They need a what?
Switch, sir.
They need what?
Switch.
Switch, yes. They need a switch. We've already connected the switch, but they need to have something in them in order for them to be able to talk to one another.
Router.
A router? No.
IP address.
Thank you. They need IP address. They need to have IP address in them so that they can be able to talk to one another. These IPs are already written here, but they are not yet configured in the devices. So let's go and configure the IP on them now. So how do I configure this IP? Let me start again so that we'll start from the scratch. So let me move this. I've highlighted everything together. I can move it to anywhere I like. Once I highlight them, I've clicked it back. So now let's pick the PC1. We know that PC1 is going to have 192.168.100.21. So let me click on it. When you click on it, you see IP configuration. If your own comes on this interface, you go to desktop. You go to desktop. So you have physical. This is how it looks physically. You have config. You have desktop. So you go to desktop. On this desktop now, you have IP configuration. You have dial up, you have terminal, you have command prompt. Just focus your attention on majorly two for now, which is IP configuration and command prompt. IP configuration and command prompt. So we come to this IP configuration. If you look at this IP, you see there is what? DHCP here. Can you see it, please? Are we seeing my screen?
Yes, sir.
Okay.
Yes, sir. We are saying.
Thank you. So we have DHCP here and we have static here. But before we remember what we want to do tonight is actually DHCP. But if I click DHCP now, I don't have a DHCP server on this network. It's going to pick an IP that is called APIPA. If you look at this place, it said DHCP failed. APIPA is being used. What is the APIPA IP? 169.254.5.26. So if there is no DHCP server on an infrastructure or in a LAN, what you will get is an APIPA IP. So sometimes you go and configure a network or you are troubleshooting an issue. If a PC is unable to get IP address from the DHCP server, it's going to get an APIPA IP. And if it gets an APIPA IP, it won't be able to access the internet. It won't be able to reach other devices on the network. In other words, it won't be able to share resources on that infrastructure. So this is APIPA IP. If you are writing, I will love you to write that down. What is an APIPA IP? An APIPA IP is the IP that is assigned to an endpoint, to a PC, to a host when it fails to discover a DHCP server on the network. So now we want to assign the IP statically to this.
Please, sir, can you repeat that definition? Sorry.
Okay, so an APIPA IP is the IP that is assigned to a device or a host on a network when a DHCP server is not available. An APIPA IP is the IP that is assigned to a device or a PC when a DHCP server cannot be found. So what actually happens during DHCP? We call it DORA. We call it DORA. Can you hear me, please?
Yes, sir.
Okay. So we call it DORA. And DORA, the word DORA means discover. That's we're going to look at those process when we start our DHCP. But let's first of all do the static IP allocation. Okay. So who can tell me what IP do we want to configure here? What's the IP we want to configure here? Hello? Can you hear me?
We can hear you, sir.
Okay. So what's the IP that we intend to configure here on this PC?
Is it private IP?
Private.
Yeah, it is a private IP. We've already written it down here. 192.168.100.21. Okay? So automatically it will pick the subnet mask. The subnet mask is 255.255.255.0. At the moment, we don't need a gateway because we are on the same network or on the same subnet. So we don't need a gateway. We're going to look at what gateway or how we can use gateway when we configure a DHCP server using a router later on. So this is .21. Once you've configured this, you can close this tab and come to the command prompt. On your command prompt, please write this down. How do I know, or how will I know if I want to know the IP that is on a laptop? If I want to know the IP assigned to my PC, you type ipconfig, ipconfig, ipconfig. So you can see the IP here now, that the IP on this PC1 is 192.168.100.21, and the subnet mask is 255.255.255.0. So if I try to ping, let me ping PC2 if it will be reachable. But the first thing to actually ping is even yourself. You can ping yourself, that is ping the PC itself, 100.21. You see it's responding. Now when you see it, reply from this and you see packet sent 4 and packet received is also 4 and packet lost is 0% loss. That tells you that okay, it's reachable, so it's able to reach itself 21. But let's see if it can reach 22, which is the next PC. Somebody should tell me, will it be able to reach PC2? Will it be able to reach PC2? Yes or no? Hello?
Time out.
Huh?
Time out.
It will not be able to, it will time out. Okay? What does it mean when it time out?
Unable to reach.
Okay? So when we say it should try to reach .22, we are going to be having what we call request timeout. In other words, it's saying I'm unable to reach it. Request timeout. So you are going to see that it's going to say packet sent is equals to 4, packet received will be equals to 0, lost will be equals to 4, and you have 100% packet loss. So it's saying I'm unable to reach PC2. You can see now, packet sent is 4. And how do you know the packet that is sent? This is the first one. Number 1, number 2, number 3, number 4. So packet sent is 4. Packet received is 0. In other words, PC2 could not receive packet from PC1. And the packet lost is 4. And it's 100% packet loss. So let's go to PC2 and configure the IP and see if we will now be able to ping it. So now let me first ping. If we do ipconfig on PC2, ipconfig, can you see that it does not have any IP? Everything is 00000. No any IPv4 on it. Okay, so and if I try to ping, there is no way we'll be able to communicate. If I ping 192.168.100.21, which is PC1, we are going to see that it's going to be request timeout 4 times. Packet sent will be 4. Packet received will be 0. Packet lost will be 4. And it's going to be 100% packet loss as well. So, because it does not have an IP now, there is no way it can communicate with PC1. So you can see ping statistics for 192.168.100.21, packet sent is 4, received is 0, lost is 4, and it's 100%. So let's go and configure the IP and let's see what will happen next. So I come to my IP configuration again and I say static. So here I say 192.168.100.22. So we said 22 should be here because this is PC2, and I close this. If I come back to my ping again and try to do ping to 21, what happens now? Can we see? Packet sent is what? 4. Packet received 4. Packet loss 0. 0% loss. So you see that immediately an IP comes into the PC, is now able to talk to the other PC. So in other words, the technology that PC used to talk to one another on a network is the IP address. Do we understand this? Hello?
Yes, sir. Yes, sir.
All right. Thank you. So we have configured for PC1, PC2, and let's quickly configure for PC3, and then we will introduce a so PC3 192.168. Okay,
Hello,
good.
sir.
Mr. Israel, please go ahead.
Mine is showing invalid command at the command prompt.
Okay, so I've said that we should just wait until we are done. So where in particular,
Okay.
so that you will not get confused, and where in particular in command prompt, right? Fantastic.
Yes.
So I will go there now. What is the command that you put in? IP config. That is IP
Yes.
config.
Yes, sir. Then it's the next phase that is
Okay,
the
when I
problem.
want to ping, right?
Yes.
So ping PING space. Then I want to ping PC1 now. 192.168.100.21. I'm able to reach it.
Oh, yes, sir.
So what was the error?
Yes, sir.
What did
I didn't put space.
you didn't put space? Okay, good. So
Yes.
you need to have your ping space, then the IP address that you want to ping. So we are
Yes.
successfully configured PC3, and we can reach PC1 from PC3, and the same thing will be applicable even if we go to PC4. Now, so let's do PC4 68.100.24, and we have this as well, and we'll close it. So IP config, once again we confirm we have that. Ping 192.168.100.22. That's PC2 is reachable, so it's going to be able to reach all of the devices. So now imagine if you have 500 PCs. Anti-Messi, if you have 500 PC, is that how you are going to be moving from one PC to the other to go and configure IP statically on all of the 500 PC? That means you might have to work for maybe a whole 1 week. Imagine if it's like 10-story buildings and cable has been made available to all of the PCs. So that is the purpose of having a DHCP server. So all these PC now, they can talk to themselves. We don't have a problem with that. They are doing fine. So now we are going to remove the static IP. We now want to configure a DHCP server. Okay, so I will pick one server here. So I come here now on these end devices. You see a server. So I pick one server here. I want to use this server as our DHCP server. Please pay attention. So we call this one DHCP server. This is the first type of server we're going to create, because we're going to have to now configure another one from a router. But here now, if you look at this whole configuration, we have not configured anything on this switch. By default, a switch is smart. Once you connect, everything is in a default VLAN 1. But don't worry, we'll talk about VLANs later. So I connect my cable again from the server fast Ethernet 0 to, let's put it on maybe port 10 or 11, port 11. So now I open this server. You see what we call services here now. This server can provide different services. HTTP, which is our web service. DHCP, are you seeing this now? DHCP 4, version 6, TFTP, DNS. I've talked about DNS. We're going to do some things about that. syslog, AAA, that's triple A, authentication, authorization and accounting, NTP, network time protocol, email, FTP, file transfer protocol, IoT, VM management, and many more. But why are we here? We are here for DHCP, which is just DHCP server version 4. So in this place, I can create a DHCP pool. Okay, so let's call it our LAN DHCP pool. LAN DHCP pool. So that is the name. Why the gateway? In this case, we don't have a gateway because we are not using a router. But we need to configure an IP on this DHCP server itself. So start IP. Where do we want it to start from? Let's use a different range of IP. Instead of using 192.168 here, let's use 10.10.10.20. It should start from 20.10 or 20.11, and the subnet mask should be 255, then 255, then 255, and dot 0. Okay, so we now enable it. You see the service here, we say enable, and we will add this. You see it's down here now that we now have our LAN DHCP. Lower here, we now see it LAN DHCP pool. So, and we can see the start IP here, 10.10.20.11, and the subnet mask is 10.255.255.255.0, and maximum user, we can have 245 users on that network. So now that we have done this, we need to configure a static IP on this guide. So let's see if on that interface, on the interface here, so we say static, let's give it an IP of 10.10.20.10, and the subnet mask is 255.255.255.0. So we've configured that, and I think we should be good to go. So if we close this now and come to this PC, okay, and close it here. So in this IP, instead of using static now, let's use DHCP. Can someone tell me something? What did you see now? Can you see that it has taken IP from the DHCP server? You will see that it said DHCP request what? Successful. And you can see 10.10.20.1. However, there's something I'm seeing here that we are not accurate with. We say that it should start from .20 or .10. So let's come back to the DHCP server here. We configured it that for the DHCP, it should start from 10.10.20.11. Okay? Oh, we said start IP here is 0, so it's supposed to be 11. So I put it to be 11 here. So we add it, already existed. So just give me a minute. Okay, good. So 11, and we add it. All right. So let's close this and go back and click on static again, and let's check our DHCP again. It's still giving us that. So what we can do is to delete this DHCP server. I can remove it and reconfigure a new one and still call it LAN pool. Let's just call it LAN pool. And we say the start IP should be 10.10.20.11. It should start from .11, and we want it to use 255.255.255.0. Okay, so we add it. Invalid IP address entered for DNS. Okay, we are not having any IP for DNS. Okay, so DHCP pool. Okay, let's just give a DNS of say 8.8.8. So add it. Gateway wants us to put gateway, so we'll put it. So, but that's not an issue. 10.10.20.1. Enter a valid number of users. Valid range is 1 to 65,000. Okay, good. So we go to .0 and have it to be this. So let's say 245. All right. Okay. I think the last one is already picking what we used before. So let's take the 11 here and see. Okay, so we just say save. That's what we do. Save here. And let's call it LAN DHCP pool. So we have this, call it save. Server pool cannot be modified or edited. A new pool, yes, that's what we want. So this is done now. And I think we should be able to get the right subnet. So let's come back here and static again, and then ask for DHCP server as well. Can you see now? It's starting from 10.10.20.11. So the first PC has picked .11 because we asked that the server should start allocating from .11, start IP address from .11. So then the second one will be .12. So we said don't use static here, use our DHCP. Can you see? DHCP request successful, and we now have 10.10.20.12. Do we understand what we are doing here, please? Or I'm doing magic? Hello?
Yes, sir.
Okay. Somebody want to talk? Madam Esther, or is it
So I
Mercy?
wanted to say that we are doing magic, sir.
We are doing magic. Okay. All right. So all you just need to know is that these PCs, this laptop, they need IP, And if I don't want to use my hand to assign IP to them statically, all I need to do is to configure a DHCP server. What is DHCP? DHCP means Dynamic Host Configuration Protocol. It helps me to configure my host automatically. So if I go to the third laptop here now and I remove this static and say it should take IP, it should give it 13. Are you seeing now? It said DHCP request successful, and we have 10.10.20.13. If I close this place now and go to my command prompt, you see that in this place before it's saying 192.168.100.23, but the IP has changed now. The IP has changed now. So I should be seeing, if I say IP config now, I'm seeing 10.10.20.13. So I should be able to ping .11, 10.10.20.11. Yes, that is PC1. I should be able to ping .12. That is PC2. Now, remember that if you look at this topology and what we have done, PC1, 2, 3, they have IP via DHCP, abi, from this DHCP. But PC4 has the old IP. Will PC4 be able to talk to the other 3 devices? Anybody want to tell me? If yes, why? If no, why? Someone talk to me.
Is no, sir, because they are carrying different uh number.
Okay, thank you. You got it right, but you explain it in an upcoming, which is fine. So this is it. Yes, they will not be able to talk to themselves because they are in different IP subnets. Okay, so the IP range of PC123 is 10.10.20 range, while the IP range of PC4. So if I try to ping, so let's even try it now and say ping 10.10.20.11, which is PC1, it will tell me request timeout. It's not able to reach it. So it's not able to talk to PC1 because the IP in PC1 is not. Now, let me now show you something. Instead of configuring this IP via DHCP, if I configure it statically and say 10.10.20.14, right? And I click close here, and I come back here, and I try to ping .11. Are you seeing it? You see I can reach .11 now. So whether you are configuring your IP statically or you are configuring it via DHCP, you will still get the same result. But so that you are not tired, so that you are not having to make mistake when you are using hand to type it statically, that is why we have the DHCP server. Do we understand that? So I will change this from static now to DHCP, and you will see that it's going to give it 14 automatically. So this is our first assignment. You configure all the PC. So I'll put it there, the DHCP pool. So if I want to write notes, I'll just come here and there's a place we look for notes. Place a note, yeah. So I'll place a note here. I say, okay, DHCP pool. Your DHCP pool is 10.10.20.0/24. So that's the DHCP pool that you have to use for on your DHCP server. So this is for,
Sorry, sir.
yeah, I'm listening.
On your own, it's like you use 10.10.20.0, Abby.
Now let me explain something. So when you hear that dot zero is the whole subnet. /24 is the whole subnet. That is .0, you have .1, 2, 3, 4. I can't be listing all of them. So I will use .0/24, the whole block. So .1 will be your router, dot 2 will be something else, dot 3 will be something else. We're going to look at those things. So this is so like the one we assign statically here, the block is actually 192. This block here is actually 192.168.100.0/24. This is the whole block there on this down. So dot 21 is for PC1, dot 22 is for PC2. So this single IP you are seeing here is covering this whole subnet, is covering these whole devices. Do you understand? It's like when you say student, when you mention student, student is covering both GS1, GS2, GS3, SS1, SS2, SS3, right? Now,
So it means, sorry, sir.
okay,
Does it mean 0 to 24? Any number from 0 to 24?
no, it means any number from 1 to 255. Okay, I will tell you the reason why we say 24 here. Let me explain that. There's what we call subnet mask. Okay, when we're configuring the IP, we have what we call subnet mask here: 255.255.255.0. How did they get that 24? This place, remember we talked about something we call octet, right? If you remember, octet. When we are converting from binary to denary, that's base 10. And we said that every digit that you are seeing is 0 or 1, 0 or 1. So this whole place, this first place, this 255 is actually 8 bits. 8 bits. 1, 1, that's 111 in 8 places. So 8 plus 8, 16. 16 plus 8, 24. So this subnet mask is what we are calling /24 here. Okay, we are still going to do subnetting. You will understand it better there. So just note that we have what we call class A, class B, and class C in IP addressing. Class A, class B, and class C. So the class C is what we call /24 that has a default subnet mask of /24, and the available IP there is between 1 to 1 to 255, and you can use one on a host and the 255. So the 1 is your, or 0 is your network, and the 255 is your broadcast. So you can actually use from 1 to 254. Okay, do you understand this? Hello.
Yes, sir.
Okay, all right. So our assignment is this. I want to delete this. So our assignment is to configure LAN statically. Is to configure time. Good, you will understand. Don't worry. When we take the second lab, you will begin to get it clearly, and nothing in technology or in networking that will be that cumbersome or strenuous. So now, so when you are doing your assignment or you are trying to build the lab now, you are configuring your own um you configure your own DHCP pool to use this DHCP pool, and first of all do the static and ping. Share your ping. Oh, I can reach this from this and from this from this, and then configure the DHCP pool. So I'm going to snip this or take a snapshot of it and send it to our platform. So I now want to do another design for us But we will end this first class here, and I will set up a new link for us, and we'll take it up from that. We'll take the second class from there. So just give me a moment to